Hey, geometry. So today we're going to get into our triangles unit. So this is our fifth unit, but this is from chapter 2 out of our book. So when you see the 2s, that's where it comes from. So yeah, 2.1, classifying triangles by sides. There's a few different. This is just classification in general. A couple of different ways we can classify by sides. So scalene is if we have no equal sides, all three sides are different. Isosceles, if we have two sides are the same, and there's some properties we'll get to come back to with that. And equilateral, if all three sides are the same length. So that's the three different ways we could have. We could have none the same, two the same, or all three the same. And those are our three different terms for that. Then we can also classify triangles by angle. And so really if there's a right angle, and there can only ever be one. You can't have two right angles in a triangle because it won't end up being a triangle that way. And remember, the angles in a triangle have to add up to 180 anyway, so a couple 90s wouldn't work. But if you have a 90-degree angle, we call that a right triangle. And so you have one right angle, and then the other two angles will end up being acute. If you have any angle over 90 degrees, like what we have here, that's an obtuse triangle. It's got an obtuse angle within it. There can only ever be one obtuse angle. You can't have two that are more than 90 degrees. And then finally we have our acute triangle where all three angles are acute. And so that is how we could classify by angles. So if we're trying to identify between those, one thing that we might have to look at, if we're not given that right angle or an angle measure, what we can do is we can clarify this with our Pythagorean theorem. So we know that the relationship between the three sides in a Pythagorean theorem follows this rule: a squared plus b squared equals c squared. So if we have a right triangle, then that should work out. And so we can check that. If a squared plus b squared equals c squared, we know that we have that perfect relationship. If, however, a squared plus b squared is not big enough, it's less than c squared, if this, basically they're saying that this kind of hypotenuse is too long for a right triangle, that means it kind of has come further than beyond a right triangle. That actually means we have an obtuse angle here for that. And of course, I should mention that A and B need to be your legs, which may not always be immediately clear. Like down here, we don't have a drawn triangle. So you always pick your two smaller ones. The hypotenuse should be the longest length. If, again, and then we're kind of checking for a hypothetical, if this was a right triangle, the hypotenuse would be the length. If that hypotenuse, quote unquote, is too long, it means it's not actually a hypotenuse, but that means you're dealing with an obtuse angle and an obtuse triangle. And if that hypotenuse is too small, that third side, that biggest side, is too small, then it's an acute triangle. And so make sure you do get that. Yeah, A and B are the smallest two sides when you're doing this. All right, so let's kind of verify on these. So if this sets up for a Pythagorean theorem, we should, if it's a right triangle, then these should equal. So I should have 8 squared plus 11 squared equals 12 squared. All right, so that is 64 plus 121. Does that equal 144? All right, and we're really kind of asking this question right now. I'm going to pose that more as a question. Well, if I add 121 plus 64, what do we get? 185. That is too big. So that's really greater than that. The hypotenuse, quote unquote, it's not actually a hypotenuse, ends up being greater than. So we're actually in this situation here where this triangle is acute. So it is not drawn really properly, but this hypotenuse is not of the proper length. It's again it's more the kind of what I'm testing as the hypotenuse is too small. So this actually is an acute angle and an acute triangle. So we can try that again here. We have 5 squared plus 12 squared. Is that equal to 13 squared? You don't have to put this in here if you don't want to. 13 squared, so that is 25 plus 144. Does that equal 169? So we add those up. 144 plus 25 is 169. Yes, it equals. So yeah, it checks out. So that means this is actually a right triangle. And then finally, if we go 5 squared plus 8 squared, does that equal 10 squared. So that's 25 plus 64. Does that equal 100? So 64, 74, 84, 89. No, it's actually, this is smaller here. So it's really should be that less than that length. This length is too long, so that actually means we're dealing with an obtuse triangle. All right, that hypotenuse didn't end up being an actual hypotenuse, but that hypotenuse was too big, and so this is actually an obtuse angle, and so an obtuse triangle. All right, so a couple more. We don't have triangles to go off of. Make sure we grab our smallest one. So I'm going to grab 6 squared plus 8 squared. Does that equal 10 squared? And so we get 36 plus 64 is 100. Yes. So 36 plus 64 is 100. 100. So yes, checks out. This is, that checks out. So this is a right triangle. And then finally here, make sure I grab the short ones, 5 and 8. So 5 squared plus 8 squared equals 13 squared. So does 25 plus 64 equal 169? Right, and I guess I'm doing, kind of checking this. And you could, like I say, you don't have to write this down. You can just leave that blank. But 25, so that's what, 89? Does that, that hypotenuse is way too long. Seems like it's actually going to be obtuse, right? So this would suggest obtuse. But if we think about this some more, this actually creates another problem here. So we'll get into this on the other side. We're not really dealing with this yet. But if I have one leg of the triangle's 8 and the other triangle is 5, those two add up to 13. So if you try and imagine like what this triangle would look like if I have my 8 and then this other side like plus 5, if I kind of do this, plus 5, that actually equals 13. And so that full length is 13. And that's actually the only way that it can stretch out to be long enough. So in fact, this is not even a triangle. It's not possible. And so there's a rule we'll check out in the next video about that rule.